Hello everyone. In this lecture, I will discuss some previous year questions of plus 2 science exam on continuity. I am Dr. Bharat Kesari Swai and let's start. Okay, so first question is for what value of a the function fx is equal to 1 plus 3x 1 plus 3x whole to the power 1 by x when x not equal to 0 and a plus eq at x equal to 0 is continuous at x equal to 0. So what is the question? What the question is asking that the function is given and it is continuous at x equal to 0. So the function is continuous at x equal to 0 and we have to find the value of a. For what value of a this function will be continuous. So we know that for continuous function your limiting value of fx at x tends to 0 because at 0 it has been asked. So limit fx as x tends to 0 must be equal to the functional value at the given point, that is f of 0, is not it? So if it is continuous function, then this must be satisfied. The limiting value must be equal to functional value. So now the functional value is given. What is your f of 0 is equal to a plus eq. A plus eq, this is your functional value. Only we have to find the limiting value, then make it equal with f of 0, then we can get a. So first find your limiting value. So limit of fx, so limit as x tends to 0, and when x tends to 0 means x not equal to 0, and function is what? 1 plus 3x to the power 1 by x, to the power 1 by x. So now to find this limit, just put 3x is equal to y, 3x is equal to y, or 3x is equal to t. Okay, here it is solved, here it is solved. Okay, so for continuity at x equal to 0, your limiting value must be equal to f of 0, and that is your a plus eq. So now directly to find the limit, directly just put t equal to 3x, 3x is equal to t. So if 3x is equal to t, then your x will be t by 3, x will be t by 3. Okay, and now since x tends to 0, x tends to 0, then your t will be also 0, because what? T equal to 3x, because t equal to 3x, as x tends to 0, your t also tends to 0. So your limit reduces to, your limit will be reduced to limit, will be reduced to limit, this is your limit t tends to 0, 1 plus t to the power 1 by, in place of x we can put t by 3. Okay, now come to the next step, come to the next step. So since it is 1 divided by t by 3, it can be written as 3 by t. 1 divided by t by 3 means what? 3 divided by t. Now come to the next step. So 3 is whole power, so we can write 3 as whole power. So limit t tends to 0, 1 plus t to the power 1 by t whole to the power 3. Now we have a formula that limit x tends to 0, 1 plus x to the power 1 by x is equal to e. This is our formula, and here only the variable is different, that is your t, but your formula is same. So that's why the bracketed term will be, this bracketed term is equal to e and the whole power is 3. So the result is what? EQ. The result is EQ. Therefore, this is the limiting value, and according to our condition of the continuity, your functional value must be equal to limiting value. So our functional value was a plus EQ and the limiting value is EQ. So EQ is equal to a plus EQ. Now cancelling on both sides, your EQ, your a will be 0. Got it? So for what value of a it will be continuous? The value is 0. So for a equal to 0, the given function will be continuous. Clear? Now come to the second question. This is also a question which has been asked in 2024 or 25. So what was the question? Fx is equal to, here fx is given 1 minus cos x divided by x square as x not equal to 0, and lambda when x equal to 0. This is the function. Same type of question. Question is what? F is continuous at x equal to 0. Then find the value of lambda. Same type of question. Okay. So same procedure. First find your limiting value. Then your functional value is given. What is functional value? F at 0 is equal to lambda. So this lambda is to be determined. We have to find the lambda. So this is also your functional value. So since it is continuous, the functional value will be equal to limiting value. So we have to find the limiting value. So the limiting value is what? Limit x tends to 0. Here it is solved. Limit x tends to 0. 1 minus cos x divided by x square. So now to find this limit, 1 minus cos x. So 1 minus cos x, we know that from the trigonometric identity, this is your 2 sin square x by 2. Is not it? 1 minus cos 2x is 2 sin square x. So 1 minus cos x will be 2 sin square x by 2. So therefore, 1 minus cos x by x square equal to 2 sin square x by 2 divided by x square. Now you can write this as what? Your 1 by 2, because this is your sine square x by 2, because this is your sine square x by 2. So we have a formula that limit x tends to 0 sine x by x is equal to 1. So now in the formula, here it is x, here it is x, and here it is x. Okay, so in every places there should be x, but here it is here sine square x by 2, but in the denominator it is only x square. So how to adjust it to put the above formula? So to adjust it, we can make it as 1 by 2 your sine x by 2 to the power x by 2 whole square, because it is x square. So x by 2 whole square, because it is sine x by 2. So we have to make your denominator in the form of x by 2. So if we take x by 2 whole square, then it will be 4 in the numerator. So I have to divide 2. So 1 by 2 will into sine x by 2 divided by x by 2 whole square. Okay. So this is your 1 minus cos x by x square. Now if you put the formula, 1 by 2 is constant. 1 by 2 is constant. Okay. And put this formula, because if you take x by 2 is equal to u, your the bracketed term will be limit u tends to 0. If you take limit as u tends to 0, because take x by 2 is equal to u. So it will be sine u by u whole square. Sine u by u whole square. And since limit u tends to 0, sine u by u is equal to 1, and then it will be 1 square. So it will be equal to 1. Finally it will be equal to, if you take this limit, it will be equal to 1, and the final result will be what? 1 by 2 into 1 square, because the bracketed term, the limiting value of the bracketed term, this bracketed term will be equal to 1. So 1 by 2 into 1 square. So finally it will be 1 by 2. So this is your limiting value, 1 by 2, and our functional value was lambda. So since it is continuous, your lambda will be equal to 1 by 2. So this is your answer. Okay, so we have to remember that your functional value is equal to limiting value, that much. So that is the case. We have to remember. This is the thing only. Now come to another question, question number 3. That it is also a very easy type of question, and the same thing we have to do here also. That here fx is defined. Fx is defined as x square minus x by a, x square minus a square divided by x minus a, as x not equal to a, and at x equal to a, function value we have to find. Functional value we have to find. We don't know what is f of a. We have to determine this f of a. Okay, so because it is continuous, because f is continuous, your functional value, what we have to determine, this must be equal to limiting value. And what is the limiting value? Limit x tends to a, at a we have to find. So that's why limit x tends to a, x square minus a square divided by x minus a, is not it? And there is a formula. If you remember, there is a formula that limit x tends to a, x to the power 2a square divided by x minus a is equal to what? 2 into a to the power 2 minus 1, is not it? If you recall the formula, you just do it. So 2 into a to the power 1, so 2a. The limiting value is 2a. This is a direct formula based question. Okay, so here you can check, the limiting value is 2a. Okay, or you can just simplify the numerator, that means x square minus a square. Direct you can put the formula, otherwise you can make it as your numerator, you can write it as x, since it is x square minus a square, so this will be x plus a into x minus a, and in the denominator it is only x minus a, so x minus a cancel, because x is not equal to a, is x not equal to a, so x minus a is not equal to 0, so you can cancel it. Okay, since x not equal to, it will be cancelled, so remaining term is only x plus a, and if you take x tends to a, so it will be a plus a, and that is equal to 2a. You can do like this also, otherwise you can put direct formula. So it is 2a, and the functional value is f of a, and that's why the value of f of a is 2a. Okay, so this is the thing we have to remember, that limiting value is equal to functional value, and in every case we can apply the same theory. Now come to another question. So question number 4, test the continuity at x equal to 0. So we have to test the continuity, whether the function is continuous at x equal to 0 or not. Okay, so this is another formula. We have just recall the formula to do the question. You just recall the formula, that we have a formula that limit x tends to 0 e to the power x minus 1 divided by x is equal to 1. So this was a formula. If you check my first lecture of the limit, we have written a formula like this: limit x tends to 0 e to the power x minus 1 divided by x is equal to 1. Okay, so here to find the limiting value, so you can take this as limit x tends to 0. You can find also a limiting value, means your LHL is equal to RHL. Okay, so because it is a formula based question, so I am applying direct formula. Otherwise you can find your LHL, you can find your RHL, just make it equal, and then the limit will be exist, and then make it equal with your functional value. This is the procedure. So since it is your formula, so that's why I am applying direct formula. So limit x tends to 0, what is your function? 1 minus e to the power minus x divided by x. And to put this formula, what we have to do, make or put minus x as y. Put minus x as y. So if minus x is equal to y, and what will be x here? X will be minus y. X will be minus y. So as x tends to 0, your y also tends to 0. Is not it? So that's why your limit will reduces to your limit will reduces to what? Limit x tends to 0, sorry, y tends to 0, y, your limit y tends to 0, your 1 minus e to the power y, because minus x we have uh, taken that minus x as y. So that's why e1 minus e to the power y divided by minus y. Okay, and you can write this is as limit y tends to 0, e to the power y minus 1, just multiply minus 1 on numerator and denominator both. So e to the power y minus 1 divided by y, and just compare with the formula, and that will be equal to 1. Okay, so this is the limiting value. Is not it? And what was your functional value? Yeah, check. This is your functional value, that is f of 0 is equal to 1. Now limiting value is 1, functional value is 1, so both are equal, so f is continuous at x equal to 0. Okay, this is how you can direct apply the formula and find the answer, find the or you can check the continuity of this function. Otherwise, here you can also use L'Hospital rule also. We have we have discussed this L'Hospital rule in our first lecture of the limit. You can see here what is the L'Hospital rule. You can separately, since it is 0 by 0 form, since your 0 by 0 form, you can just separately differentiate the numerator and denominator, and it will be e to the power minus x by 1, and put x is equal to 0, so it will be e to the power 0, and that will be equal to 1. So directly you can apply also L'Hospital rule. Otherwise, just take it this as I have discussed, just put the formula and get your answer. Limiting value is equal to functional value. Okay, so question number 4 complete. It is continuous at x equal to 0. Next come to question number 5. So what is your question number 5? What it is asking that at how many points your given function fx is equal to 4 minus x square divided by 4x minus x cube discontinuous. So we have to find the discontinuous point. So discontinuous point means what? The discontinuous points means the points where the function is not continuous. Is not it? The points where the function is not continuous. So therefore, so not continuous means what? We have three conditions. One is it must be defined. What are the conditions to be continuous? To be continuous, we have first condition is what? We have three conditions. We have first condition is what? Function must be continuous, means function must be defined. Function must be defined. Second means limiting value means LHL is equal to RHL. Limiting value must exist. And third condition is what? This limiting value must be functional value. Limiting value must be equal to functional value. Suppose point is a, so limiting value as x tends to a, f should be equal to f of a. So these are the conditions. So first we have to check whether at every point function is defined or not. If it is defined, come to the next point, limiting value exists or not. If this condition is also satisfied, then come to the third condition, this limiting value must be equal to functional value. Limiting value must be equal to functional value. So one by one we will check. Okay, so now, so first condition is function must be defined. So here you can see, if I write the function as fx equal to 4 minus x square divided by x into 4 minus x square, x into 4 minus x square. So you can cancel 4 minus x square, or 4 minus your numerator and denominator. Otherwise you can see in the how you have to check the discontinuous points. You can see where the function is not defined. So how we can see here, the denominator, when your denominator will be 0, when your denominator will be 0, your function will be undefined. Is not it? If your denominator will be 0, that means x into 4 minus x square is equal to 0. If this denominator is equal to 0, that means what? Your x equal to 0 or 4 minus x square equal to 0. If 4 minus x square equal to 0, then x square equal to 4, then x will be plus minus 2. Okay, so we got 3 points. X equal to 0 is 1 point, x equal to 0 is 1 point, then another 2 point is x equal to plus minus 2. So if you put these values in the denominator of the given function, put x equal to 0, your denominator will be 0. Put x equal to 2 here, then your denominator will be 0. Put minus 2 here, then denominator will be 0. So if your denominator will be 0, then what type of term you will get? 4 minus x square by 0. If I put x square equal, means x is equal to 0, then it will be 4 by 0. 4 by 0. So 4 by 0 is what? It is undefined. It is undefined. Similarly, if you put x equal to 2 and x equal to minus 2, your denominator is also 0. So therefore, functions, the given function is not defined at x equal to 0, at x equal to 2, at x equal to minus 2. So at these 3 points, function is not defined. So not defined means discontinuous points. At these 3 points, function will be discontinuous. So that is our question. That was our question. How many points are there where the function is discontinuous? So therefore, there are 3 points where the function is discontinuous. 0 plus minus 2. Understood? Clear? Now come to next question. Question number 6. This is our question number 6. Examine the continuity of this function. Examine the continuity of this function. So continuity means we know that limiting value must be equal to functional value. First, you can see here functional value is what? At 0. f0 is equal to 1. At x equal to 0, function is 1. So f0 is equal to, this is your functional value. Now find the limiting value. So first, for the limiting value, we can find LHL is equal to RHL. So first find LHL. So LHL, LHL will be equal to limit x tends to 0 minus, x tends to 0 minus your fx, x tends to 0 minus fx. So x tends to 0 minus fx, that means your what fx, you can see here LHL is equal to, you can also write this as your working formula, that is your limit h tends to 0 f of 0 minus h, and that is equal to limit h tends to 0. So 0 minus h means f of minus h. So put minus h in the given function. So e to the power 1 to the divided by minus h minus 1 divided by e to the power 1 by minus h plus 1. Now if you put h tends to 0, this is here, you can see this is 1 minus h, 1 divided by minus h, it is also 1 divided by minus h. Okay, so if you put h tends to 0, h in place of h put 0, what we will get? E to the power minus infinity, because 1 by h, minus 1 by h. If you put h equal to 0, the denominator will be 0, means will be tends to 0. So if denominator is 0, then we will get 1 by 0, that is your infinity. So e to the power minus infinity minus 1 divided by e to the power minus infinity plus 1. Now what will be the value? What will be the value? E to the power minus infinity means what? 0. E to the power minus infinity is what? E to the power minus infinity is e1 by e to the power infinity, and 1 by infinity we know that it is 0. So e to the power minus infinity will be equal to 0. So 0 minus 1 divided by 0 plus 1. 0 plus 1. Okay, so what is the final answer? It is minus 1. It is minus 1. What is minus 1? Left hand limit. Similarly, come to your right hand limit, RHL. So right hand limit means limit x tends to 0 plus fx. Now that is equal to, using your working formula, you will write f limit x tends to, h tends to 0, f of 0 plus h. F of 0 plus h. Now this is your limit, h tends to 0. So you can put h, f of h. So it will be e to the power 1 by h minus 1 divided by e to the power e to the power 1 by h plus 1. Is not it? E to the power 1 by h minus 1, e to the power 1 by h plus 1. Now you can see here, if I take common your e to the power 1 by h, then what will get? 1 minus 1 by e to the power 1 by h divided by, in the denominator it is also e to the power 1 by h into 1 plus 1 divided by e to the power 1 by h. Okay, now come here, that will be equal to, that will be equal to, that will be equal to, that will be equal to what? We have got what? Your limit h tends to 0, e to the power 1 by h, 1 plus 1 by e to the power 1 by h divided by e to the power 1 by h, 1 plus 1 by e to the power 1 by h. This is what we got, and that is equal to, this is cancelled. E to the power 1 by h, e to the power 1 by h cancel. Now see here, limit h tends to 0. This is 1 plus, this is 1 plus, so 1 by e to the power 1 by h means, if you take e to the power minus 1 by h, if you take this term to the numerator, it will be minus, divided by 1 plus e to the power minus 1 by h. Now take h tends to 0. If you take h tends to 0, that will be e to the power minus infinity again, divided by 1 plus e to the power minus infinity, and we know that e to the power minus infinity is 0, so it is 1 divided by 1, that is equal to 1. That is equal to 1. So your left hand limit was minus 1, and your right hand limit, as we found, 1. That's why left hand limit is not equal to right hand limit. So limit does not exist. Limit does not exist. So if limit does not exist, so therefore your function is discontinuous. Function is discontinuous. Okay, so the given question, your function is discontinuous. Okay, so next come to another question. Come to another question, question number 7. Question number 7. So what is your question? Examine the continuity at x equal to 0. Examine the continuity at x equal to 0. Okay, so what is the given function here? Fx equal to this 1 by x plus greatest integer of x. What it is this? This is your greatest integer. We have already defined in the previous class that what is your greatest integer function. You can check at x less than 0 and minus 1 when x greater than equal to 0. Now greater than equal to 0 means when x greater than 0 it will be minus 1. When x equal to 0, when x greater than 0 means what? Greater than equal to means x greater than 0 it is minus 1. Yes, x equal to 0 means it is also minus 1. So therefore, if you find the functional value f of 0 will be minus 1. The functional value is f of 0 that is equal to minus 1. Now come for your left hand limit. So if you will get left hand limit x tends to 0. Here you can check limit x tends to 0 minus x tends to 0 minus. So 0 minus means it is less than 0. Is not it? 0 minus means it is less than 0. So less than 0 means how it is defined? 1 by x plus greatest integer of x. Greatest integer of x. Now if you use your working formula, it will be limit h tends to 0, h tends to 0, and this is your f of 0 minus h, f of minus h. So minus h plus minus h greatest integer of minus h. Now therefore that is your limit h tends to 0 and it will be 1 divided by minus h, and since it is minus h greatest integer of minus h, what will be this? And h tends to 0. You can check here h tends to 0 and it is negative also. So negative, that means this type of maybe minus 0.1 or minus 0.2 or minus 0.001. This is the value of h. So maybe it is very small but tends to 0, and it is positive and minus sign is there, so minus, so it is minus 0. Suppose it is minus 0.001. This type of number will be there. So minus 0.001. So greatest integer of minus 0.001 means what? It will be minus 1. So it is your minus 1. So therefore, if you take now h tends to 0, then it will be 1 divided by 0 minus 1. The value is minus 1. So the value is minus 1. So we got what? Functional value is minus 1 and your left hand limit is your minus 1. And now come to right hand limit. Come to right hand limit RHL. Right hand limit RHL. So what will be RHL? Your limit x tends to 0 plus fx. So now here you can see for x greater than 0, x tends to 0 plus means what? X greater than 0. Greater than 0 means how it is defined? It is minus 1. So the limit x tends to 0 plus, it is minus 1. Function is minus 1. So the result will be minus 1. So what we got? LHL is equal to minus 1. Functional value is minus 1. And your right hand limit is also minus 1. Okay, so all are equal. So therefore function is continuous at x equal to 0. Function is continuous at x equal to 0. Clear? Now come to another example. Final example. This is your test the continuity of the function fx equal to 2x minus 1. Greatest integer of 2x minus 1. Greatest integer of 2x minus 1. At what? At x equal to half. Point is what? Half. At 1 by 2 we have to check the function's continuity. The continuity of the function. Now what will be the left hand limit? Just check your limiting value first. So left hand limit means your limit h tends to 0, f of 0 minus h. So that is equal to limit h tends to 0, f of 0 minus h means 2 into minus h minus 1 greatest integer. So result is what? Limit h tends to 0. Limit h tends to 0. So therefore it will be what? sorry, because we have to find at x equal to 1 by 2, so that's why it is your half minus h, half minus h, sorry. Okay, we'll do it again. So limit, what we have to find, limit x tends to half minus 2x minus 1, greatest integer of 2x minus 1, because we have to find at x equal to half, we have to check at x equal to half, so that's why it is x tends to half minus. So half minus means, you see here, it is less than half, is not it, less than half, or you can write limit h tends to 0 f of half minus h, because our formula is f of a minus h, so half minus h, that's why it is your limit h tends to 0. So f of half minus h means just put half minus h in place of x, so 2 into half minus h minus 1, greatest integer. So therefore it will be equal to limit h tends to 0. So if you multiply 2 here, so it will be 2 into half cancel, it will be only 1 minus 2h minus 1, greatest integer. So now 1 and minus 1 cancelled, only the remaining part is minus 2h. So limit h tends to 0 minus 2h, greatest integer, minus 2h, that is your greatest integer, is not it? So if it is minus 2h, see here, so h is tends to 0, it's positive number, so minus 2 into something, minus 2 into, so it will be minus 2 into, you can see, suppose h is equal to very small 0 0 1, so minus 2 into 0 0 1, so what will be result? Minus 0.002, and we have to find the greatest integer of this point, so what will be the result? The result will be minus 1. The result will be minus 1. Okay, so your left hand limit is minus 1. Now come to right hand limit. So right hand limit what? RHL is equal to limit half your x tends to half plus f of x, and you can write limit h tends to 0 f of half plus h, so that is equal to limit h tends to 0, so what is your function? 2 into half plus h, 2 into half plus h minus 1, this is your greatest integer of this. Now limit h tends to 0, limit h tends to 0, if you multiply 2 here, it will be 2 into half means 1 plus 2h minus 1, greatest integer of this, so 1 minus 1 cancels, so only the remaining part is limit h tends to 0 2h, greatest integer, is not it? So 2h means it is always positive, and the same thing, the number, suppose h is 0 0 point, is very small, okay, it is very small, so the greatest integer of 2h will be what? Suppose h is 0 0.001, so it will be 0 0.00, means if you multiply 0 0.001 with 2, so it will be 0 0.002, and the greatest integer of 0 0.002 will be what? It will be 0. It will be 0, because we know that greatest integer is what? The smallest, the greatest integer less than this. It will be the greatest integer less than 2h, so it will be 0. Okay, so right hand limit is 0 and the left hand limit was what? Minus 1. So your left hand limit is not equal to right hand limit, so limit does not exist, so therefore function is not continuous. That means discontinuous at x equal to 1 by 2. At x equal to 1 by 2, function is discontinuous. Okay, here functional value you can also find according to the means from the question. Functional value is what you can see here. The functional value is what at x equal to half. Functional value is what f of half. F of half. The money f of half means what 2 into half minus 1, and that is your half 2 to cancel. 1 minus 1 is 0. Greatest integer of 0 is 0. This is your functional value. So functional value is equal to right hand limit. Functional value is equal to right hand limit. This is your right hand limit. This is your functional value. Both are equal, but left hand limit is not equal. Left hand limit is not equal. That's why function is discontinuous at x equal to half. Clear? So in this way you can do the problems. Okay, thank you. In the next lecture we will come with a new topic. Okay, so subscribe the channel and share with your friends. Thank you.